Hello, everyone. I want to go through an example of adding vectors by components. So here we have three vectors, A, B, and C. These are all velocity vectors. And I would like to find out what the result is. So what we want to find vector R. That is the result of adding vectors A plus B plus C. All right, so remember the first step in adding vectors by components is I don't want to work with these vectors themselves. I would like to break the vectors down into their x and y pieces. So I carefully draw the x part of A and add to it the y part of A. By the way, technically the y part of A is really here. That is, if when we talk about projectile motion or we talk about forces, the x and y vectors have the same starting place as the vector ay. But what we're doing is we're moving the vector tip to tail to add it together to complete our right triangle. So I'm going to do the same with vector c. And right away I notice that the y part of vector c is pointing down in the negative direction. That's important to note. And notice I'm not breaking b into x and y pieces because b has no x piece. It only points vertically in the y direction. So now that I have my components drawn and labeled, I can calculate what the components of these vectors are. So let's start with vector A. AX is the adjacent side of adjacent to the angle. So I note that cosine 45 degrees will be equal to AX divided by A, or that AX is going to be equal to 30 times cosine of 45. And that works out to be 21.2 meters per second. Now, AY is opposite the angle, so that would be the sine function. But since it's a 45-45 triangle, I know that the two legs, the AX and AY, have to be the same size. So I can save myself a little time and note that AY must also be equal to 21.2 meters per second. Now for vector B is only pointing in the y direction. So that means the x part of vector B is simply equal to 0. I do not draw a triangle if it is not pointing at an angle. The y part of vector B must be equal to 15 meters per second because it's all in the y direction. Vector C, again, I have to be careful because the y part is negative. I know that Cx is adjacent to the angle. That's going to be C times cosine of 30 degrees. So Cx is going to be equal to 25 times cosine of 30. So the x part of vector C is equal to, so I take cosine of 30 degrees times 25. So this is going to be equal to 21.7 meters per second. So to find Cy, I note that's going to be the size of vector C times sine of 30 degrees. Or that Cy will be equal to 25 times sine of 30. Well, sine of 30 is just a half, so a half of 25 means that Cy is equal to 12.5 meters per second, but that would be wrong if I calculate my r vector with it. I need to note that Cy is negative, so I need to put a negative sign in there because that component is pointing down. All right, now that I have my components, I'd like to put them together to find out what vector R is. But to do that, I simply add up all the x bits of my vectors and add up all the y bits. So Rx will be equal to AX plus BX plus CX, or Rx, the x part of my answer, is going to be equal to 21.2 plus 0 plus 21.7. Well, that works out to be Well, that'll be 42.9. Similarly, our y is going to be equal to 21.2, the y part of A, plus 15, but minus 12.5. So the y part of my vector is equal to 23.7 positive. So now that I know what Rx is and I know what Ry is, we can put it together to draw our result. We don't have to worry about putting these A, B, and C tip to tail anymore because I've broken them up into X and Y components. So to complete my R vector, I simply need to use the value of these components. So I put Rx to the right because it's positive, and I note that Rx is equal to, well, that's 42.9 meters per second. There is, to the tip of Rx, I need to add the tail of Ry. So Ry will go up in the positive direction because Ry was positive. If Ry came out to be a negative value, I would go downwards instead of up. So Ry is equal to 23.7 meters per second. And now I can draw in vector R the actual result of adding A plus B plus C is found by simply using Pythagoras to find out the value. So for vector R, the size of vector R will be the square root of the x part squared plus the y part squared. So the size of R is equal to the square root of 42.9 squared plus 23.7 squared. So the size of vector R equals that works out to be 49.0 meters per second. To find the angle, I need to use an inverse tangent function. So that's tan inverse of the y side over the x side. That is, the tangent is opposite over adjacent. So I'm doing the inverse tangent of the opposite side over the adjacent side. This will work out to be the inverse tangent of 23.7 divided by 42.9. Which gives me an angle of 28.9 degrees. And there is my answer. All right, so it's a divide and conquer strategy. We take our three vectors. We don't work with them directly. We break them up into x and y pieces. Be careful of the signs. To find your result of adding those three vectors, you simply add up the x bits, add up the y bits, and then just construct the r vector. No need to place the original vectors tip to tail.